So here we're basically putting everything together we've learned so far. Okay, so we've learned that each measurement has a margin of error. It's due to the limitation of the device. But what happens if you combine measurements, right? What happens when you combine measurements, when you put a bunch of them together? What about when you keep removing an amount from a larger amount, a larger batch? What happens then? Okay, so it could be removing an amount from a larger batch or adding a bunch of measurements together. Okay, what happens then? So the total or combined uncertainty is the sum of all uncertainties present. Okay, so this is important here. I'm going to use a different color for this. The total combined uncertainty is the sum of all uncertainties present. This is due to the fact that each time something is measured and added to a total, the uncertainties also increase. The margin of error increases because something is measured repeatedly. It may seem insignificant in most sectors, but it is very important to consider in some industries. For example, a plane weighing all the items being loaded on board of the plane. The pilot needs to take into account that the actual loaded weight may vary significantly. Because every time they put your luggage on the scale and it goes off on the belt into the plane, every time the luggage might be off a little bit, just a little bit, just a little bit, right? So they have to make up for that. This is due to the combined uncertainties. Similarly, a gas station needs to be aware that the amount of fuel remaining in their holding tanks may be higher or lower than expected. Every time someone draws fuel to fill up their car, a measurement is taken. Each time the uncertainty increases, right? So the fuel pump, you gas up, it says like 25.32 liters. Another car comes by and 50.758 liters or so forth, right? And so all of those uncertainties keep on increasing and combining. So here's one example for you, okay? Maybe before we do this one, I'll give you a mini example right here because this is for study sheet purposes. So let's say you have the following measurements. So example, okay, you've got 1.5, let's go milliliters, plus or minus 0.1 milliliter. And you're going to add, maybe you have another amount that you're going to add to this. You're going to combine these two. Let's say that one is 2.5 milliliters plus or minus 0.2 milliliters. Give me the total amount that you have in this, that you've mixed together. So what happens here is every single measurement has its uncertainty next to it. Measurement uncertainty. So when you add them together, you get 4. Please keep the number of decimals the same. I would not drop the 0.0 because it's important. You wouldn't be marked wrong, but I think it's good. And then we also add these ones. Okay? So what would that be? 0.3 mLs. Okay? This part right here is what we would call the combined uncertainty. This is the part that I want you to remember, right? And guess what? Could we have a max and a min out of this? Yes, we could have a combined max and a combined min. We do the same as before. We add and subtract. Okay? But I need to tell you this, another mini example right underneath it because we won't need that space. Example, let's say you have a piece that is 8.2 feet plus or minus 0.4 feet. Right? You have a piece of wood, that measures that. And now you're going to cut off a piece. Let's say we're going to cut off 4.0 feet plus or minus 0.3 feet. Why do they have different uncertainties? It doesn't matter. It was used, different devices were used to measure it. 8.2 minus 4 is what? 4.2 feet? Guess what's going to happen with the uncertainties? I'm going to add them again. You add them every single time. Even though you're cutting off and it's calling for subtracting, we always add these two up. So you have what? 0.7 feet. This is your combined. Highlight that. So what's the point of these two examples? The fact that you always add. You add. Over here, the second example I just gave you, you also add. You always add the uncertainties. I'm going to highlight that as well. You can see that all, hold on, right there. So I highlighted this one here, that you always add uncertainties. You add uncertainties no matter what. So I would say these examples are good to have under combined uncertainties. Under precision measurement, you're going to have a section that says combined uncertainties. Have these examples there. Maybe one, maybe two. Okay. So let's do an example that involves a little bit more work. Okay. Let's, I'm going to cut this, chunk this off like this. I don't want it to be like mixed in with this example that I'm about to do. 3 pieces of fabrics are being sewn together. That means you're going to add them up, right? Determine the precision and the uncertainty for each piece. So for this piece, what's my precision again? 0.1 centimeters. My uncertainty is 0.05. Precision here. Can we just agree all of these are going to have the same precision and therefore the same uncertainty? It just happens to be the case. So I'm going to copy paste everything from here on. I'm not going to walk through every single example. So A is done. Check, right? A is completed. I found the precision and uncertainty for each piece. Calculate the total length and the combined uncertainty. You want the total length and the combined uncertainty right next to it. Why am I saying that? Why am I underlining it? Because sometimes, if I could just have your attention for 1 second, sometimes it says calculate the total, the combined uncertainty only. In that case, we would only want to add on our uncertainties, right? That's it. That's all they want. That's the one you're going to circle. That's the one you're going to say, that's my answer. But in this case, they want the total length and the combined uncertainty. So basically combining this and this all together. So I'm going to say combined length or total length. You know what? I'm going to be creative here. I'm going to just make a line here, and we're going to add this up. That gives us 95.8 centimeters. Oops. And we're going to go big, plus or minus. We're going to add up all the uncertainties. What's the easiest way to do this one if they're all the same? 0.05 times 3. Please do that, because there have been examples on the provincial exam where you put 50 of the same pieces together. I don't want you to be adding 50 times, okay? You go 50 times one of the uncertainties, and that's it. So this is the total length. And this is the combined uncertainty. Total length, total uncertainty, clearly labeled. I know that you know what's being asked here. So even if you were to answer like this and they had only asked for the combined uncertainty, you'd still get full marks because you're clearly telling us what's what, okay? That's all we're asking for. Okay, C. What's the shortest and the longest possible combined length? They're asking for min and max. For max, it's 95.8 plus 0.15. For the min, it's 95.8 minus 0.50. Use your calculator, of course. Okay. And that's 95.95. That's the longest possible piece I can expect. 95.65 is the shortest piece I can expect. I'm going to pause here and ask you to try the first question on page, the second question on page 26. Page 26, the UPS question, because it's similar to what we've done here. And I'll do more examples tomorrow where it's subtracting, okay? Just do the one question. That's all I'm asking.